Hello everybody and welcome to exercise 2 on page 25 of the workbook. Here's another exercise where they're giving us graphs of functions and asking us to sketch the graph of the derivative. Okay, let's start with part A here. So they're giving us the graph of a function g. I'm going to go ahead and just label it. And we'll start this problem the same way that we've started problems like this before, by asking, are there any places where this graph has a horizontal tangent line? Okay, and I notice two places where that happens, maybe about there and there. And so because the slope of our function is 0 at those 2 points, it tells us that the y value of the derivative has to be 0 at those same 2 locations. So it gets us started. Okay, and then kind of zone by zone, we're going to fill in the rest of the graph of the derivative of g. Maybe start with this stretch of our function over here to the left. Okay, on that stretch, do you see positive tangent line slopes or negative tangent line slopes? Okay, if I draw tangent lines, they look positive to me. And because the slopes are positive, that means that the y values of the derivative have to be positive. Okay, so first stretch of our derivative graph would look like that. Okay, and then we'd continue to the next section of the graph between here and here. And notice that our function is going down. We're going to be getting negative tangent line slopes there, which means that our derivative graph would be below the x-axis, maybe have that general shape. Okay, then we come to the stretch of the graph between here and here. Okay, our graph is going up, so we're going to get positive tangent line slopes, which means that our derivative graph is above the x-axis. And then we come to this point here. Okay, remember we had a name for a sharp corner like that. It was called a cusp, a place where the slope changes suddenly. And at a point like that, there's not really one way to draw a tangent line, and so that causes the derivative to be undefined, which means that we're going to have an open circle at that point. Okay, and then, let's clear away a little of the clutter here. Okay, we come to the very last stretch of g, which is over here, and that's going down, which means that we're going to get negative slopes. Notice that there's a really sudden transition from positive slopes to negative slopes, so the derivative graph is actually going to jump down here. And then the question becomes, how do we draw the rest of our derivative graph? We know that it's going to be below the x-axis, but what do you think? Is it going to look more like this or more like this? Okay, those are two different ways that we could draw it below. Now, to answer that question, what we could do is draw in a few tangent lines and see if that might help us. Okay, so the slopes are all negative, you can see that, but where are the slopes steeper? Notice that this is steeper. We're getting a really steep negative slope there, and as you go left to right in this direction, those slopes are getting closer to 0. Okay, they're not as steep. So that means that since the tangent line slopes are actually getting less steep, the y values of our derivative should be getting closer to 0. Okay, so that would force us to draw this more like this. Okay, the y values start out really negative, but they get closer to 0 because those slopes are getting closer to 0. All right, and there's our best estimate of what the derivative of g looks like. And we are ready to move on to part B here. Okay, so this time we're given the graph of a function f, and they'd like an accurate graph of the derivative. Okay, what's kind of interesting about f is that it's composed of line segments. Okay, so if we first focus on the right-hand half, can you tell from the scale what the slope of that line is that I just kind of highlighted there? You'll notice that the rise and the run are both 1. Okay, we're going up 1 and over 1, so the slope is 1. That means that because the slope is 1, the y value of our derivative should be 1. Okay, it stays constant because the slope of the original function is staying constant. Okay, and then what about over here to the left? What's the slope of that part of our graph? Okay, well there, if you measure rise over the run, we're kind of going down 3 and over 2, so we actually get negative 3 halves for that. Okay, so that means that because the slope is negative 3 halves, the y values of the derivative have to be negative 3 halves. Okay, and then finally, what's going on right at the center here? Okay, well again, that's a sharp corner on our graph, and so because it's a cusp, the derivative should be undefined. It causes the derivative to be undefined, and so we're going to get an open circle there and there. Okay, and so those two pieces together would be the graph of our derivative. It's in two different pieces again.